So this is Mallikarjun, working as assistant professor in the department of Flickr IARE. So today we are going to discuss about one more topic in our subject, that is steady state analysis of parallel RL circuit. Up to now we have seen the different combinational circuits in terms of series, like series RL circuit, series RC circuit and series RLC circuit. From now on we will go with the steady state analysis of a parallel combinations like parallel RL circuit, parallel RC circuit and also parallel RLC circuit. Now coming to the circuit diagram representation of a parallel RL circuit. So as we know that it is an RL circuit, we will have two elements in it. One is an resistor and another is nothing but what? It is an inductor. Now what we need to do? We need to take these two elements and we need to connect them in parallel. As we know that when two or more branches are connected in parallel, the voltage across each and every branch will be same. Suppose let me say that an AC voltage is applied to this particular circuit called V, and let me say that the resistor is indicated by a R, inductor is indicated by L. So according to the parallel branch phenomena, voltage across the resistor, that is VR, voltage across the inductor, that is VL, and also the supply voltage will be equal as these three elements are connected in case of a parallel. So in parallel branches voltage will be same and in series branches current will be same. Now let me say that the total current flowing into the circuit is I, and the current flowing through the resistor is given as IR, and the current flowing through the inductor is given as IL. IL. So by using the Kirchhoff current law, that is KCL, we are trying to generate the expression for the total current flowing in the circuit, as well as you will calculate the admittance of a circuit, then we will calculate the phase angle, then we will calculate the power factor of the parallel RL circuit. We will go one by one. So this is the circuit diagram representation of a parallel RL circuit, where the supply voltage is given as an AC supply. Let me represent that particular voltage as V. So in case of a parallel branches, please remember this point. Voltage across each element will be equal to the supply voltage, that is VR equal to VL equal to V, and the total current I is given as I, and the current flowing through the resistance is given as IR, and the current flowing through the inductor is given as IL. So we know that in general the voltage across the inductor is given as I into R, and the voltage across the inductance is given as what? I into JXL. If I want a value of this particular current, that is IR equal to VR by R and IL equal to VL by J into XL. So these are the expressions for the current that are individually flowing in case of an element called resistor and also an element called inductor. Now you will see the circuit diagram representation here. R, L, current flowing through the resistors, that is nothing but what? IR, current flowing through the inductor, that is IL, total current flowing into the circuit is I. So by applying the KCL at this particular point, what does KCL state? The sum of the currents entering into a node should be always equal to sum of the currents leaving out of the same node. A node is nothing but a common point or a junction where the different elements meet. Now you can see a dot which is represented here. This is called as a node, where because inductor is connected to the same point, resistor is connected to the same point, and one more element called source voltage is also connected to the same point. So what is the number of currents entering into that particular node? Only one current, that is IT. And what are the number of currents that are leaving out of the same node? One is nothing but IR and another is nothing but what? IL. So by using KCL, that is Kirchhoff current law, the sum of the currents entering into a node should be always equal to sum of currents leaving out of the same node. So IT equal to IR plus IL. So as it is a parallel branch, I have said clearly that VR and VL will be the voltage across resistor and inductor, but voltage across all these elements will be same as they are connected in parallel according to parallel branch phenomena. Now by using this particular expression called IT equal to IR plus IL, we will try to calculate the value of a admittance of a particular circuit, admittance of the given circuit. So in general, how to calculate the value of a admittance of a given circuit? Here I know the value of IR. What is the value of IR? VR by R. And what is the value of IL? VL by J into XL. VL by J into XL. As we know that VR equal to VL equal to V. Why? Because according to parallel branch technology. So how I can write? IT equal to V into 1 by R plus 1 by J into XL. Then after I can replace the same expression as I by V equal to 1 by R minus J by XL. And I by V is nothing but what? Generally it is considered as an admittance. Generally it is considered as what? It is considered as an admittance. This is how you need to calculate the value of a admittance of the circuit by using the expression which I got by applying a KCL at this particular node. So first, in order to calculate the value of admittance, I have used the expression by applying the KCL. Sum of the currents entering equal to sum of the currents leaving out of the same node. By that I have got the expression as IT equal to IR plus IL. IT equal to IR plus IL. So I know the value of IR which is represented as VR by R by using the general expression. Similarly, I know the value of IL. The expression for IL is considered as VL by J into XL. But I know that as it is a parallel branch circuit, voltage across the each element will be same. That is, VR will be equal to VL will be equal to V. So I am replacing the value of VR as VL as V in the next step. I am taking the common parameter. I by V. In general, it is the general formula to represent the value of admittance of a given circuit. So this is how you need to calculate the admittance of the given circuit. Admittance of a given circuit. Given circuit. In order to calculate that particular admittance, you need to utilize the KCL at that particular node. Whatever the expression that is obtained by using the KCL, that is sum of currents equal to sum of living currents at a particular node. By using that, you will calculate the value of I, and the general expression to calculate the value of I is I by V, or else it can also be written as 1 by R minus J by XL. 1 by R minus J by XL. J by XL. So this is how you are going to get the expression for the value of admittance for the given circuit. By have applied the Kirchhoff current law. By using that, I have got this particular expression, and I know the value of IR. IR is considered as what? VR by R. And what is the value of IL? IL equal to VL by J into XL. By adding these two parameters and by substituting this particular thing, VR equal to VL equal to V, I am going to get this value of admittance. Y equal to 1 by R plus 1 by J omega L, where XL can be written as omega L, or else it can also be written as 2 pi FL. Or else this expression, where R is the admittance of the resistance R in this YR, and YL is nothing but what? Admittance of the inductor L, which can be represented by 1 by J omega L, or else if I take the J notation or J operator onto the numerator side, it will become as minus J by omega L or 1 by J omega L, both are right. So this is the expression for the admittance of a parallel RL circuit. Parallel RL circuit. Now we will go to the phasor diagram representation. So as it is a parallel circuit, the voltage across the each branch which is present in a given circuit is same. Voltage across the each branch which is present in a given circuit is same. So in simple way, I can say that I need to take the voltage as a reference in order to draw the phasor diagram. So it will be easy if you take the voltage as a reference, or else you can take the current as a reference and you can draw the phasor diagram for a parallel RL circuit. As the voltage across the each branch which is connected in the circuit are same, I am taking voltage as a reference here. Now depending upon the properties of the elements that are connected in a circuit. So what are the elements that are connected in a circuit? One is a resistor and another is an inductor. So what is the property of a resistor? Current will be always in phase with the value of a voltage, where the phase difference is maintained as 0 degrees. Similarly, the property of inductor is current will always lag the value of voltage. Current will always lag the value of voltage, where the phase angle is how much? 90 degrees. Current will be in phase with the value of voltage in case of a resistor. This is for inductor, this is for resistor. This is for resistor. By using these two properties, now you need to plot the phasor diagram for a parallel RL circuit. Parallel RL circuit. parallel RL circuit. So what is the first step I need to do? I need to take the reference position. As the voltage across each element that is present in a given circuit is same, I am taking voltage as a reference. Now by using the property of a resistor first. What is the property of a resistor? Current will be in phase with the value of voltage. So let me say that this is IR. And what is the phase difference between IR and V? It is 0 degrees. Now coming to the next element, IR inductor. So what is the property of an inductor? Current should always lag the value of voltage by how many degrees? Lagging. So 90 degrees, and let me say that this is my IL and the angle between them is 90 degrees. So this is the general phasor diagram representation of a parallel RL circuit. And what are the different steps? Thus I can take the resultant like this, where this resultant is considered as what? I, which is equal to IR plus IL. Which is equal to what? IR plus IL. So in order to draw the phasor diagram, we have 4 steps here. The first step is taking a reference position. The second step is by considering the properties of a resistor. The third step is considering the property of inductor, and the last one is drawing the resultant. So this is the general phasor diagram representation of a parallel RL circuit, and this is the waveform representation of a parallel RL circuit. So as we know that voltage will be in phase with the value of a current with respect to resistor, you can see these two waveforms, the phase angle difference maintained at each point is 0. As we know that current is lagging the value of voltage by 90 degrees, you can see the current is lagging the value of 90 degrees at each point for a because of voltage. So this is the waveform representation of a parallel RL circuit, and this is the phasor diagram representation of a parallel RL circuit. Now coming to the next thing, that is what? Phase angle calculation. So you can calculate the value of a phase angle for a parallel circuit with respect to 2 parameters. One is with respect to the currents that are flowing in the circuit. So what are the different currents? One is inductor current and another one is current that is flowing through the resistor. Or else you can also calculate the value of the phase angle by using the expressions of a resistor or else the expressions for an inductance XL. How we will see the expression. So in general, in order to calculate the value of a phase angle, you need to consider the phasor diagram again. So what is the phasor diagram obtained? So this is nothing but what? My voltage. This is IR and this is IL and this is my what? I. So by using the phasor diagram representation, I can say that this has some IL. This is tan phi. So in general, what is the formula to calculate the value of a tan phi? Tan phi is nothing but what? Opposite side by adjacent side. So with respect to this, what is the opposite side? Opposite side is nothing but what? IL. And what is the adjacent side? The adjacent side is considered as what? IR. So by considering the value of tan phi from the phase angle representation, I can calculate the value of a phase angle. So from this expression, I got the value of tan phi as how much? Tan phi equal to IL by IR. And in order to calculate the phase angle, that is phase angle equal to tan inverse of IL by IR. So this expression is got from the phase angle. So in order to calculate the phase angle, first you need to draw the phasor diagram in a right approach. Then by using the phasor diagram, you need to calculate the value of a phase angle phi by implementing a formula for tan phi. And in order to get the expression, the same phase angle not in terms of currents, but you want the same expression in terms of resistance or reactance, just substitute the value of IL as V into V by J omega L, and similarly substitute the value of IR as V by R. So by substituting these two parameters, I can get the value of tan phi. Tan phi equal to IL by IR. Just substitute those two parameters. IL is V by omega L, IR is V by R. V gets cancelled and the expression is R by omega L, where omega L can also be written as XL. So this is how. So in order to calculate the value of a phase angle, first you need to calculate the value of a tan phi, and that tan phi can be calculated by the phasor diagram. So in order to calculate the phase angle or power factor or whatever it may be with respect to the parallel RL circuit, the phasor diagram approach is very important. So by using the phasor diagram, I can represent the value of a phase angle in terms of inductor current to the resistor current, that is phi equal to tan inverse of IL by IR, or else I can represent the value of a phase angle in terms of resistance and reactance, where the expression for that particular phase angle is considered as phi equal to tan inverse of R by XL. Phi equal to tan inverse of R by XL. In the similar fashion, by using the same phasor diagram, we need to calculate the value of a power factor. We need to calculate the value of a power factor, and the general expression to calculate the value of a power factor for parallel RL circuit is given as, you know that the power factor in general is represented by what? Cos phi. Cos phi. Take the parallelogram approach. This is phasor diagram approach. IR. This is IL, and this is nothing but I. Let me say that this has some IL cos phi. So cos phi in general, it is represented by adjacent side by hypotenuse. What is the adjacent side? IR. What is hypotenuse? I. So cos phi equal to some VR by V or IR by I. If it is IR by I, again I need to represent what is the value of IR. You need to represent, you will get the value of cos phi as R by Z. What is R? Resistance offered by the circuit, and what is Z? The impedance that is offered by the circuit, where I can replace the value of Z as 1 by I. You know the formula for the admittance, it is considered as a reciprocal of a resistance, reciprocal of the impedance. This is how you need to calculate the value of a different factors from the phasor diagram representation. One is nothing but a phase angle with respect to the value of a current that are flowing to the circuit, or else you can represent the same phase angle by using the resistance and the reactance offered by the circuit. And similarly, by using the phasor diagram approach, you need to calculate the value of a cos phi, that is nothing but what? Power factor. Power factor. This is how you are going to calculate the different parameters by using the phasor diagram approach in case of a parallel RL circuit. So we will meet in the next class and we will discuss about this some other parallel combination, that is parallel RC circuit. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.